Okay, question 3 on the worksheet has a kind of similar flavor to question 2. Let's try a half angle formula this time. So I'm looking at cosine of b over 2. Let me go back to my formulas. So cosine of b over 2. That's kind of making me look at this formula right here. So I know that I'm going to get, let's see, let's go back to my worksheet. So I'm going to be looking at plus or minus the square root of 1 plus cosine beta. But, looking at my formula again, because the angle beta over 2, so the angle beta over 2 is between 0 and pi over 2. So I know that cosine beta over 2 is positive. And so that's why I just need to figure out the positive square root of 1 plus cosine beta over 2. So I don't have to worry about the negative square root. And now plugging in, well, what is cosine beta? So the adjacent is 4. What is the hypotenuse? Well, it's going to be the square root of 4 square plus 3 square. That is the square root of 16 plus 9. Square root 25. That's 5. And some of you might remember that this is you might remember this something like 5-4-3 triangle or something like that. So we know that cosine theta must be 4 over 5, right? Adjacent over hypotenuse. So plugging in, simplifying, you should get that cosine beta over 2 is 9 over 10. Okay, next let's try this guy. Let's try sine of alpha plus beta. And I'm using my sum formula. So that's sine alpha cosine beta, cosine alpha sine beta. And let's try to figure out first what sine alpha is. So with alpha, I know that my opposite is 5. What's my hypotenuse? Well, again, I can use a Pythagorean identity. It's going to be 12 square plus 5 square and the square root of that. And you can work this out. It's going to work out to be 13. Okay, so that side is 13. So that's why I have my opposite, which is 5 over hypotenuse 13. And then cosine beta, we've already computed that. That's 4/5. Cosine alpha, so our adjacent was 12 and we figured out the hypotenuse 13. And then just like before, sine beta is going to be, just the way we figured out cosine beta, sine beta is 3 over 5. Doing the algebra, simplifying a bit, we should get 56 over 65.